In the vast expanse of our universe, where celestial bodies dance in cosmic ballets, NASA has uncovered a phenomenon so immense, so voracious, it's devouring entire galaxies. Welcome back to our channel. Today, we're diving into the latest discovery from NASA that's shaking up our understanding of the cosmos. Imagine a cosmic entity so massive, so mysterious, that it engulfs entire galaxies like a giant cosmic vacuum cleaner. This enigmatic object, detected by NASA's powerful telescopes, has been dubbed the galactophage. The galactophage isn't your ordinary celestial body. It's a supermassive black hole surrounded by a swirling accretion disk of gas and dust, resembling a monstrous cosmic maw. What's fascinating about the galactophage is its sheer scale. It's like a cosmic beast, consuming anything that comes too close, including entire galaxies. The galactophage's gravitational pull is so immense that it devours stars, planets, and anything else unfortunate enough to cross its path. We believe that the galactophage could be the result of a rare cosmic collision between multiple galaxies, where their central black holes merged to form this colossal entity. This cosmic merger unleashed a gravitational juggernaut, capable of consuming galaxies at an alarming rate. The discovery of the galactophage raises profound questions about the evolution of galaxies and the fate of our universe. Could there be more of these cosmic behemoths lurking in the depths of space? NASA scientists are now on a mission to unravel the mysteries of the galactophage and its role in shaping the cosmos. With cutting-edge technology and innovative research, they're peering deeper into the universe than ever before. Deep within the cosmos exists an enormous and colossal entity, an unexplained force exerting pressure on everything and propelling all galaxies, including our own Milky Way, into the unknown. Not only that, but astronomers might have discovered something much more massive and enigmatic. What is this force that we don't understand, and will it wipe out the universe? INTRO, finding objects in space, is a skill that astronomers possess, especially with today's advanced equipment. However, this time, we need to focus on something situated toward the constellation Centaurus, beyond the Milky Way. The view from Earth is obscured on that side of the Milky Way by the gaseous, dusty, and starry disk of our galaxy. This area is known as the zone of avoidance by astronomers. And deep within that zone is something known as the Great Attractor. Advancements in radio and X-ray astronomy allowed scientists to investigate the zone of avoidance. It turned out that the center of the local group of galaxies, situated in the Virgo cluster, is being approached by our Milky Way and the nearby Andromeda galaxy. They all advance toward the center of the Laniakea supercluster together. The Great Attractor is the attraction zone located at the center of this megacluster. Its center is located 147 million light-years away from Earth, with an estimated diameter of 300 million light-years. Scientists discovered a sizable supercluster of galaxies in this region, now known as the Norma cluster, hidden under a cloud of gas and dust. An estimated 1,000 trillion solar masses make up its overall mass. However, additional research using X-rays as part of the Clusters in the Zone of Avoidance project revealed that the number of galaxies in the Great Attractor region is significantly smaller than originally believed. It was estimated that the mass of the Great Attractor exceeded 10 million billion times that of the Sun. However, scientists discovered that its mass was barely a fraction of what they had initially thought. The Malmquist bias was thought to be responsible for the majority of the region's observed galaxies. The number of faint objects in space increases with distance. Consequently, only the brightest items were visible. This leads us to incorrectly identify these objects with nearby, unrelated portions of the sky. Consequently, denser galaxies appear to be more prevalent in particular areas of space. Thus, it's possible that the Great Attractor is a mirage that is deceiving us into believing in an unreal object. It might just be a region of space with an unusually high concentration of galaxies, rather than a super attractor at all. Galaxy clusters in the vicinity cannot be drawn in by the Great Attractor due to its insufficient mass. What then lures them to the Laniakea supercluster's core? In an attempt to find solutions, scientists started looking for a structure with a stronger gravitational attraction, and they were soon successful. This is the Shapley supercluster, a group of about 20 clusters located 650 million light-years away from Earth and containing 8,000 galaxies. 10 million billion solar masses are included in this supercluster. It is the largest creation from the Milky Way within a billion light-years. ESA's Planck satellite is already capturing unusual photographs of the center region of the Shapley supercluster as it searches the sky for the oldest cosmic light. The two galaxy clusters, Abell 3558 on the right and Abell 3562 on the left, together with a few minor groupings in between, are depicted by the largest pink patches. A model of a structure situated in the opposite direction of the Shapley supercluster has also been produced by scientists. There, the dipole repeller, a region of incredibly low density, was found by astronomers. The extreme gravity of the Shapley supercluster pushes celestial bodies out of this area of space. Consequently, there is probably no matter in the dipole resistor. Furthermore, the dipole resistor is linked to the flow we see because underdense portions of space repel matter just as much as overdense regions attract it. However, the full structure of the gravitational web in the vicinity of the Great Attractor remains unclear, despite the discovery of the massive supercluster Shapley. A portion of the Milky Way's velocity, according to University of Australia professor Matthew Collis, is yet unknown. The gravitational forces of the Shapley supercluster, the Great Attractor, and the Virgo cluster were all calculated by the researcher, and the results don't add up. It was discovered that the expected speed of our galaxy is approximately 50 kilometers per second, 31 miles per second. According to Professor Collis, it's because of the enigmatic structures concealed beneath the Milky Way. It is plausible that the Vela supercluster is one of the ones that scientists have already discovered. About 850 million light-years away from Earth, it is hidden beneath a dense layer of gas and dust. It's a massive cluster. With a radius of roughly 370 million light-years, it is home to roughly 100,000 galaxies. There are hundreds of billions of stars shining on each of them. The supercluster may be the biggest in the Milky Way's neighborhood if its size is verified. The discrepancy between the Milky Way's actual speed and the universe's expansion due to gravity may be explained by the Vela supercluster. In the meantime, 883 galaxies in the zone of avoidance have been examined by astronomers. A third of them have never been seen before. The Australia-based Parkes radio telescope was used for the study. First, 3 galaxy concentrations, NW1, NW2, and NW3, were discovered by astronomers. Next, 2 more clusters, CW1 and CW2, were discovered. Since each galaxy has 100 billion stars on average, the discovery of hundreds of galaxies hidden behind our own galaxy indicates that a staggering number of mass scientists were unaware of this information. Their gravitational pull probably modifies the velocities of the nearby galaxies. However, the mystery remains unsolved even after this. Even now, the Milky Way is expanding faster than it ought to. Additionally, researchers are still trying to understand the nature of the motion of the Milky Way and other galaxies in the local group, as well as hidden sources of gravity. Dark matter is one theory that could apply here. Massive formations of regular matter are not as effective in drawing in galaxies with gravity as their unseen clusters are. Alternatively, the dark flow, a different hypothesized force of the universe, might accelerate galaxies. This is the term used to describe the sudden motion of galaxy clusters, frequently in the direction of an unidentified mass outside the observable universe. By examining data from the Wilkinson Microwave Anisotropy probe on over 1,000 clusters, scientists at NASA Goddard Space Flight Center have found indications of this behavior. This is extensive research that encompasses a sizable portion of the cosmos that can be observed. The dark flow is 2.5 billion light-years beyond our solar system, farther into space than previously believed, according to the paper's authors. It is headed toward the Great Attractor, followed by the constellations Centaurus and Hydra. One idea holds that this enigmatic black flow is linked to another world via a fictitious multiverse. It is believed that one bubble of the basic energy field gave rise to our cosmos. If so, other bubbles could have formed into many more worlds. Additionally, the gravitational pull of a mass from a parallel universe might have produced the dark flow. Since there is a continuing discussion about this notion, scientists are really taking it into consideration. Meanwhile, a group of international astronomers did an intriguing study of the Great Attractor. 30,000 galaxies and their clusters were tracked in motion within 350 million light-years of Earth. Researchers have charted the motion of galaxies from the time the universe was only 1.5 billion years old to the present. Based on the present brightness and position of the galaxies in space, they computed their paths inside the Milky Way. Based on the findings, the researchers created an interactive model that displays the Perseus-Pisces supercluster, the Great Attractor, and the area around the Virgo cluster. The model shows the motion of galaxies toward the center of attraction in both clusters and individual cases. Most significantly, however, scientists projected the paths of all these celestial bodies, including the Milky Way, for the future. They discovered that most clusters will not be able to move toward the centers of gravity due to the universe's fast expansion. Even an interactive simulation of the future motions of galaxies in this region has been built by scientists. The model covers a period of time from the early stages of galaxy formation to a point in the future when the universe will have nearly doubled in age. According to the study, in the next 10 billion years, there will only be a small number of significant mergers in extremely dense clusters. As of right now, space remains a great mystery to us. Furthermore, solutions frequently raise new queries. Which additional abnormalities in space are you interested in learning about? Tell us in the comments below. Keep checking back here for more astounding findings and spectacular events occurring throughout the universe. I appreciate your attention.